How you doing, guys? Bioinformatics guy here with another video of the series Python for Bioinformatics. In the last video we talked a little bit detail about the list comprehensions, and in this video we will be talking about set comprehensions and dictionary comprehensions, and towards the end of the video we will also see how you can work with the conditional comprehensions. So let's start coding. Now the set comprehensions are exactly similar to list comprehensions. The only difference is that rather than using these square brackets, you have to use these curly brackets. Okay, and let me show you a pseudocode for set comprehensions. It would be expression for item in collection. Okay, so here you have to add the expression that you want to evaluate, and then you are iterating over a collection in this for loop here. So let's create a new cell and try to create a new set comprehension. But before we do that, I want you to show the difference between list comprehensions and set comprehensions. The main idea is that in set comprehensions there are no duplicates. So even if you have duplicates in the collection that you are using in set comprehension, those will be removed once you get the set at the end. So to show you the difference, I have to create a string and we can name it seek, and this will be our collection for this example, and we can put ATGC, and at the very end I'm adding a duplicate A character over here. And then let's try it with our very old and well-known list comprehension and then see how many characters you get in the list. So give us a base for base in seek. Oh, I have to run the previous cell as well, and now you can see that we got A, T, G, C and A as well. And if I add a new cell and then I create a set comprehension using the same code inside a new pair of brackets, the curly brackets, base for base in seek, and let's see what we get now. You can see that we just got only 4 characters here, and the duplicate A is not here in the set that we got as a result of set comprehension. So this is really useful when you want to remove the duplicates from a given collection. We will talk about the use cases of this thing later on, and before that I have to tell you about the dictionary comprehensions. Now creating dictionary comprehensions is a bit complicated as compared to list and set comprehensions, but it's very useful. So the pseudocode goes something like this. You have curly braces just like dictionary comprehension, and over here you know that in a dictionary you have a key and then you have a value. So in dictionary comprehension you will have a key expression, then just like we define a dictionary with a colon, we will write the value expression, and then you will start your for loop for key in key comma value and collection. Let me reduce the size. So this is your key expression which will act as the key for the dictionary, and this is your value expression which will be the value of that specific key. Here you start the for loop. This is your collection over here, and you are iterating with the key and value. Now you need to note down that over here we have more than one iterators. We have this key and value. One thing you need to note here is that the collection that you will use for dictionary comprehensions should just have two elements, list or tuples. So like if you give it a list, then in the each element of list should have an either tuple or list. Now this might get a little bit convoluted at the moment, but now it's perfect time to use the information that we collected from the FASTA file, which has the info fields and the sequences fields. Let me grab the previous functions and then I will show you what I'm talking about. Things will get much clearer. We will need these two functions. We need this, and then we need the last function. Let me simply run this, and then I will call this function here, read FASTA sequences, with seek dump.txt, and I have to put this in the inverted commas. And you can see now that we get a list of lists. So there are two brackets. It means that this is a list which also contains several lists, and each list contains two elements. The first element is our information and the second element is the sequence itself. So here the list ends and the next list starts. Now we will create a new function, and then we will create a dictionary by using dictionary comprehension. So let me clear this up, and then we will define a new function, def, and the name of the function could be make indexed sequence dictionary. Very long name, I know, but it's okay. So we will give it file name, and then here is going to be just one return statement. And since we are going to use dictionary comprehensions, we will start with the curly braces, just like that. Then our key is going to be info, because that's information, and our value is going to be seek. Okay, and then we will start our for loop for info comma seek in, and now we need to get the entries, and we can get those entries by using this very nice function, read FASTA sequences here. And then we have to give it file name, and let me reduce the size. Now this is the really nice one-line function, and now we have to call this make index sequence dictionary function, and we will call this by seek dump.txt, and let's run this and see the magic. So here we have this dictionary. You can see by the curly braces we have this dictionary, and then the key starts from here and goes till here, and then we have our sequence. Now it has created a really nice dictionary. Now what the benefit of creating the dictionary is, you know, that we can access the values if we want to get very specific kind of sequence. If we have the accession numbers and we want to extract the sequences, we can simply do that by using dictionary comprehensions. So that's all about dictionary comprehensions. Now what if you do not want to add each and every value in your comprehension, and you want to filter out the elements from the collection that you are using? So for our rescue, we have conditional comprehensions. Pseudocode for a conditional list comprehension would be expression for element in collection. Now comes our test. We will check if, and here we can perform any kind of test. We can do several kind of things that we want to do after this if statement. Okay, so in order to demonstrate the conditional comprehensions, I need to create a list of some sequences that contain RNA and DNA sequences. So we will call this list RNA DNA list, and over here we will put some sequences. Let's put ATGC, a DNA sequence, and then we can add TCGA, and then an RNA sequence could be AUGC and UCGA. Okay, now our list is ready. Let's run this and create a new cell. So first of all, we need the sequences which are of RNA. Give us seq for seq in RNA DNA list if. So in RNA, you know that you have uracil instead of thymine. If U in seq, so it will check that if there is U in the seq, only then it will add it to the list comprehension. Let's run this, and you see that we just got AUGC and UCGA. Okay, and now I know that you really want to try this, how we can get the sequences which are of DNA. So we will create the cell similar to that, and we will just change this U with a T, and now you can see that we just got the DNA sequences. So that's how list comprehensions can help us, and we can also use if statements and conditions as well. You can also create nested list comprehensions, but I won't go into that much detail at the moment. Maybe in future I will show you. So that's pretty much it for this video. In the next video, what I'm gonna do is I'm gonna create a new file which will have all of our functions that we have created so far, and then we will try to use them, and then we will see how we can import them. I would highly recommend you to watch that video, so that if you are following this series from the very beginning, then you will be able to sort out, you will be able to organize your code in such a nice way that it will be really helpful for you in the future. So thank you very much for watching. If you have any questions, comments or concerns about this video, you can comment down below. I would be happy to help you out. And if you want to see the code, you can go to my GitHub repository. If you want to read the blog post, you can hop on to the Bioinformatics Guy website. You can also join Bioinformatics Guy's community, which is a Facebook group. All the links are going to be just below the like and subscribe button. And if you want to know what I do other than programming, you can check out my blogging channels. So thank you so much again, and I will see you around in the next video.